Okay, let's continue with 2.5 and put the observations that we determined on the first page, putting them together as a set of rules for the transformations of functions. So we saw if there is any number added outside the function, there's a number added outside, that's going to shift it up C units. If there is a number subtracted outside the function, that'll shift it down, just what you would expect. The direction is what you would expect. Plus number up, a negative number down. These are the ones that are tricky. If they add a number inside the function, if it's inside, then it's going to shift it left or right, and it's opposite of what you would think. A plus number inside the parentheses will go left, C units. A minus number that comes inside the function will shift it right, C units. And what I mean by inside, it's like if you have an x minus 2 squared. Notice the 2 comes inside the square. Let me do plus to be consistent. Or if I had, let's say, the cube root of x minus 4. Notice the minus 4 comes inside the function. The 2 comes inside the square. Those are inside numbers. And the transformations will follow the left or right rules. Okay, well, let's take a look at a number in front. What we saw on the previous page, if there was a number in front, it was a vertical stretch or a vertical shrink. If the number was bigger than 1, like the number 5, we saw a vertical stretch. And if the number that comes in front is between 0 and 1, like that fraction of a half, it's a vertical shrink. Finally, the last thing we saw had to do with a negative. If the negative was outside or the negative was inside. So if the negative comes in front of the function, it's a reflection across the x-axis. And if the negative comes inside the function, it's a reflection across the y-axis. So we have to think about those reflections. Reflection just means a mirror image. If the negative is outside, it reflects the x. If the negative is inside, it's going to reflect the y. Now let's take all these rules for shifting and reflecting and apply them to these functions down here. A little hard to see, but you can see it on your note sheet. This is an x cubed minus 7. Well, we know the basic shape from the cube from the previous page is that sort of S shape, and the negative 7 from the transformation we see up here, the negative 7 is a negative outside or separate from the cubing function. So that means it's going to shift down 7 units. So it's the basic shape, that S shape, but we're going to shift it down 7 units. Now let's go ahead and graph that. Normally it starts at 0, 0, but we're going to shift it down here to the 0, negative 7. And we want to mark that final resting spot and then just draw our cubing shape. Now, I won't be taken off for artistic ability here, but just do the best you can in drawing that cube shape. Now, I really can't read this next one. I know that's an X, I know that's a plus, but I am not really sure. Let me check that out. Okay, I realize it's X plus 5 squared plus 3. And there's a negative in front, so let's go ahead and talk about all the different transformations we have going on here. What does the negative in front do? Well, if there's a negative in front, my shape is going to reflect across the x-axis. So we see a reflection. It's going to reflect across the x-axis. I also see a +5 that comes inside the function. If there is a plus number that comes inside the function, it's going to go left c units. So this is going to go left 5 units. The +3 is coming separate from the squaring function. And when your value comes separate, it's up or down, and so this one's going to go up 3. So we're going to make a reflection. We're going to shift it left 5 and up 3. That doesn't look like a U, but there we go. So let's get an idea. Let me do this in several parts. Let me do the initial in yellow. So it's a squaring function, so our parabola normally looks like this. We're going to take it and reflect it. So the reflected version is going to look like this. Now we're going to take that reflected version and go left 5 and up 3, which would put the final resting point there. So the final graph of this, I'll do it in black, would look like this. A parabola that opens down with a final resting point at -5, 3. So the original, the reflected version, and then the version that's been shifted. Let's look at the next one and recall what we know about transformations. Absolute value, we know that that basic shape is a V shape. 3 in front gets into my stretches and shrinks. So what category does 3 fall into? Is it going to stretch it or is it going to shrink it? Well, 3 is a number bigger than 1, so this tells me it's going to stretch. So the absolute value normally looks like this. Stretching it basically means you're holding it both on the top and on the bottom, and you're stretching it vertically along the y-axis. So this shape here is going to squeeze in and become much thinner. So the stretching of the absolute value will make it come in like that. So stretching makes it thinner. It's probably thinner than that. I didn't do a really good job of graphing that one. It's going to be thinner. Distinctly thinner. So, let me go and write down here. We see that it's a vertical stretch. Okay, let's look at the next two. Actually, there's 3. Recalling our transformations from the top of the page, let's look at first the basic shape. The square root shape is the arc shape. The negative outside is going to reflect across what? Will reflect across the x-axis. If the negative is out front, it's across the x-axis. And this +5 is inside the square root function, and inside numbers will either shift it left or right. Opposite of what you think, so a +5 means we're going to go left 5. So let's put the regular shape here. Here's the regular square root arcing out to the right. Let's take it and reflect it across the x-axis, which means it's going to arc out to the left. Ooh, so sorry, that's y-axis. Yeah, let's do that again. We'll reflect across the x-axis. It's going to arc down here. Now let's take that reflected version and move it left 5. 1, 2, 3, 4, 5. So it's going to rest right there. And at this final resting point, we'll arc it out to the right. So that final resting point being -5, 0. Always mark the final resting point, which I didn't do over here, but it's 0, 0. So the regular shape is this arc, the basic shape. We reflect across the x, looks like this. Scoot it left 5, and we'll have it centered right there at -5, 0. Let's check out the next one. Got two things going, actually three things going on here. The negative out front is going to reflect across the x-axis. The negative inside is going to reflect across the y-axis. And the 2 is going to move it up 2 units. Let's again take it in parts. Here is the basic shape. It looks like that. Let's reflect the x-axis first. So it's going to look like this. Now let's take it and reflect it across the y-axis. So if I take this shape and do a mirror image on this side, it's going to look like that. Basic shape, reflect the x, take that answer, reflect the y. Now what do I do with this reflected version? Move it up 2 units. So it's going to stand right there. So taking this shape and moving it up 2 puts its final resting point at 0, 2, and it's going to arc downward after the 2 reflections. Reflect across the x, then reflect across the y. Move it up 2 units. Finally, the last one. This number in front is one of those stretch-shrink situations. And because it's a number between 0 and 1, it's going to be a vertical shrink. It's like a compression along the y-axis. You squeeze it along the y-axis. And the basic shape is the cube root of x, which we saw earlier to be like the x cubed shape just on its side. So the regular cube root looks like this. We're going to take that and compress it vertically along the with respect to the y-axis, and that's going to shrink it. So instead of it arcing that high, it's not going to arc quite as high. So we're shrinking it, compressing it, top and bottom along the y-axis, and just causes it to shrink, to get smaller, thinner, however you want to describe that. Center point at 0, 0. We haven't moved that center anywhere.